How can a figure be reflected? So yes, lovely picture. Perfect example of a reflection. So for those of you who are not aware, a reflection gives a mirror image of something. Okay? A figure can be reflected across any line. Here's our line. We call it a line of symmetry or maybe a focus line. So everything on the top is a reflection of the bottom. Same size, same shape. What do you think of when you hear the word reflection? What are some things you think of, Aiden?
Like when you look at your mirror.
Mirrors.
Like a lake when you can see yourself.
A lake or a shiny body of water. Repeating something, copying. Anybody else? When they think of reflection, what do you think of? Two things. Okay, good. Okay, so you might think of looking into a mirror or a shiny surface. Now we're going to take a second. We're going to play a little game. We're going to take 2 minutes. Okay? And you are going to work with a partner. Natasha, I want you to sit across from America for me. Okay? Now let me explain to you how this game works. You are going to reflect what the person across from you is doing. Not saying. This is a physical activity. So I'm going to model for you, and then I'm going to give each of you a minute to do the same. So we're going to practice. Now that everybody has had a little experience with reflection, we're going to take a look at what happens when you have to have that line, and whether it's imaginary or real, that line is really important. When a figure is reflected, the size stays the same and the shape stays the same, just like yesterday in our translations. Reflections can be drawn and shown on a grid just like what we did yesterday. So they put in a line of symmetry or a focus line and they flipped it. Now the most important thing of this focus line, America, is that your original shape is, you have to think about how far it is from the focus line. So in this case, we have one spot to the left. That means when we're starting our new shape, our reflected shape, it goes the opposite direction, one spot. Not up or down, but just one spot. Now, if that focus line was this way, then it would be different. What do you observe about the distance between the original image and the line versus the new image and the line? They are the same. Plot points the exact same distance from the line for the new image. How would a translation and a reflection be different from each other? Okay, that's a possibility. Could you, with a reflection, we can only move in one direction, correct? We're going to move to the right or to the left, up or down. But in a translation like yesterday, you can do both. So you can move diagonally. A reflection flips an image. It's another name for a reflection, is a flip. A translation actually slides the image. Are either of these considered a reflection? No. No. If they were moved a little bit, they would be. Okay, so let's take a look. I want you to tell me if this example is a reflection. Raise your hand, and all I need to know is yes or no. Natasha. Say it again. What did you really say? No. Okay, tell me why. Okay, because this little jutted out spot right here is pointed to the left, so on the other shape it should be pointed the other direction because we're flipping it over that line of symmetry. Cole, did you have a question?
Yeah, why does it have to be having a line coordinate? Why does it have to have numbers?
It doesn't have to. You're going to see some today that's not on a grid like this, but you're going to see others that are on a grid, and you're going to have to try to make that reflection based on those numbers. Okay? How about this one? Raise your hand again. Yes or no? Lingen?
Yes.
Yes. How about this one? Eileen? Yes. This one, Aiden? No. How many of you feel like you are really good at looking at something and in your brain being able to turn it and flip it? Some of you are really good at that. Mrs. Wajer is not. I really, really have trouble with that. It's hard for me to turn something around in my brain. So when I look at this, at first I think, well, sure. But really, it's not, because if we were to take this shape right here and flip it, this tall part would be aiming down here. So we know that's not going to work.
Do you understand?
Do you understand? All right. Now I want you to look carefully at shape A. Which of the other shapes is a reflection of A? Will. Exactly. Now, why isn't D? Because B and D are the same. Why isn't D a reflection of it? Eileen?
Because B is all the way on the top and D is all the way at the bottom.
Yeah, see, D would have been a reflection and a slide. So it flipped and then it also moved. So there needs to be that line of symmetry between them. And they need to stay even. This time, I want you to look at rectangle A. Right here, rectangle A. And I want you to tell me which of those other shapes would show a reflection of that shape. Powers? C is correct. Look at pentagon D, this one right here. Which one is a reflection of that? Darius? Say it again. E is correct. Why isn't C? Because C and E look exactly alike. All of them look exactly alike. Why not C?
C is up.
There you go. Look at triangle C. Which one is a reflection of triangle C? Emma? E is correct. Take a look at trapezoid B. Which one is a reflection of trapezoid B? Cole? D. Here's our line of symmetry right about here. It is tricky. They just moved it far away. All right. Next, I would like you guys to open up your textbooks just for about a minute, and you can share with the person next to you. We're going to look at a few pictures here. It is page 469.